This is an advanced 3-phase motor drive module that I just received this morning. It's only about the size of a cardboard box lid, and the main drive chips are integrated on the module, including 3 power half-bridges. These are made up of N-channel and P-channel MOSFETs, forming a 3-phase half-bridge circuit. There's also a 7805 voltage regulator chip on the circuit board, which carefully provides a regulated power supply to the main controller. From this, we can also infer that the drive voltage for the 3 half-bridge MOSFETs should be 5 volts. The main control chip is model ZH64581 in a QFN package, but there is still no detailed information about this chip available online. Next, I've set up a simple test circuit to check out its functions. I created a footprint for this module and designed the PCB component based on its dimensions. Designed a simple test circuit. Using a single-sided PCB, I created the test circuit with a 1-minute board making method. After 1 minute, the test circuit board was ready. And next, I proceeded to solder the components. I have meticulously cleaned the delicate circuit board with high-pressure steam, and now I am diligently getting ready to thoroughly test its functionality. Using a spring-loaded holder, I supply the 12V working power source to the circuit. Now, let's test the static power consumption of the module. With no external load connected, the module's static power consumption is 14.3 mA. Next, I'll connect the module's output to a 3-phase brushless motor. For a 3-phase brushless motor, changing the phase sequence will reverse the motor's direction. Now, let's test the module's power consumption with the motor connected. The module's current is still 14.3 mA. This is because no speed pulse signal has been sent to the module yet. Next, I'll use a signal generator to apply speed pulses to the module. The pulse signal is connected to the test circuit board using alligator clips. However, there's a problem now. It seems the motor isn't responding. The motor is still stationary. The applied pulse signal is a 1 kHz square wave with a 50% duty cycle. So the question is, why isn't the motor working now? The entire module is still in a static current state. Later, I discovered that the connections were wrong. The module's output wasn't connected to the motor's input. Now, reconnect the module to the motor's input terminal. Use a DC power supply to provide the 2 volts DC control voltage to the module's speed control terminal. You can see that the motor starts running at this point. After the motor starts running, hold the motor's output shaft by hand. It seems that the motor has a certain degree of speed stability control. Changing the control voltage should be able to change the motor's speed. After carefully increasing the applied voltage, the rotational speed also noticeably increases. Now, provide a square wave signal with a 50% duty cycle to the speed control terminal again. At this point, the motor does not run, which indicates that the speed control of this module is achieved through voltage, not by the input pulse frequency or duty cycle. Next, let's test the module's speed feedback signal. When the motor is stopped, the speed feedback signal is at a high level. Now that the motor is running, this signal has changed to a low level. If the motor is forcibly stopped, you can see that the speed feedback signal once again outputs a high-level pulse signal. Therefore, the speed feedback signal can be used to obtain information about the vibration speed of the motor. Using an oscilloscope to measure the module's output voltage waveform, you can see that the voltage waveform is a sine-modulated PWM signal with a PWM period of about 60 microseconds. This module measures the phase current by driving the left side of the MOSFET. Here, we conducted a preliminary test of the brushless motor driver module, produced by England Technology. It's only about the size of a bottle cap, and the motor only needs 3 wires connected to the module to achieve speed control. It features speed feedback and uses an analog voltage for speed control. The simple interface of this module makes it very convenient to use.